So now in this video I'm going to explain the next subtraction instruction as a SBB. So the meaning of this SBB means subtract source and borrow from accumulator. So later we'll see that their detailed functionality. As of now, first of all we have to look at for their opcode. So their opcode is simply here SBB, and as a operand it should have this 8-bit register. So here this is 8-bit register, and we can take it here as a memory also. So either we can use 8-bit register as a operand, or we can use the memory also as a operand. So now we can understand their functionality. So let's say for example, if the instruction is taken here as a SBB, subtract this content of the register B along with the borrow from the accumulator, and after performing this subtraction store the result into accumulator, and as per the subtraction result reflect or modify there all the flags also. So here let's say before going into the detail of this analysis, first of all I am taking here this accumulator content as I am taking here as a 37H. The B register content here I am taking here as a 3FH, and this carry which is called in the case of like addition, whatever the flag it is perform as a carry, the same bit it can be used as a borrow in the case of subtraction. So this I am considering here. Previously, before execution of this instruction, it is set. So even though if it is reset, then we have to perform the operation accordingly, or if it is set, then we have to perform the operation accordingly. So here how the result is going to be stored. So what will perform here? This is the content of A. From here it is going to subtract the content of this borrow along with the content of this carry flag also. So here this can be written in this fashion also, that from the accumulator this first of all the content of B register along with this carry or borrow status can be added together, and then take the 2's complement of this result here, take the 2's complement of this result here, and that should be added with the accumulator content. So ultimately it will provide you the result of A minus B minus CY. So here what I had considered, this B register content I had considered here as a 3FH. So here this 3FH in this B register, this 3FH can be written as 0011, and for the F it is 4 times 1, and carry status or borrow status we had considered here as a 1. So 1 should be added to their MSB bit. If it is 0, then 0 will be added. It means it is not going to change this result of B plus this borrow, means the content of this B register along with the borrow. If the borrow is 0, then there is no change in the result, but in this case I had considered borrow as a 1. So from the first stage 1 plus 1 sum will be 0, carry will be 1. So 1 plus 1 0, carry will be 1. 1 plus 1 0, carry will be 1. So 1 plus 1 0, carry will be 1. 1 plus 1 0, carry will be 1. 1 plus 1 0, carry will be 1. So 1 plus 0 1, and this is 0. So this is the result it came. So this is giving here as a 40H. This is giving here as a 40H. This is 4, this is 0. So it is here 40H after adding this borrow status along with the B register content. But here we have to take the 2's complement of this result. So the 2's complement of 40H is equal to what? This will be 0, 0, 0, 0, 0, 0, and this is the first non-zero element, so that is 1, and after then it is 0, so that will be interchange 0 to 1. So this is 1100 and 4 times 0 here. So this is the result obtained after taking the 2's complement of this result, whatever we obtained as a 40H. So now this 2's complement result should be added to the accumulator content to get this subtraction result. So here this A is having, this content of A is 37H. So this can be written 0011 and 7 can be written as a 0111. So this is 37H. Now this 2's complement of 40. So 2's complement of 40, how it is written? It is 1100, then 4 times 0. Now we have to perform the addition operation. So 1 plus 0, it is 1. Again 1 plus 0, it is 1. 1 plus 0, it is 1. 0 plus 0, it is 0. Then again 1 plus 0, it is 1. 1 plus 0, it is 1. 0 plus 1, 1. 0 plus 1, 1. And carry generated here is 0. So the carry status here at this stage it is showing, but as per the process what I had explained in the 2's complement subtraction method, whatever it is coming here, the carry, while doing this addition, we have to take the complement of this as a final status of this carry or borrow. So here it should be written as a complement carry. So complement carry means this 0 will become 1 here. Now rest of the result will be as it is 1 1 1 1 0 triple 1. So this MSB bit is 1 and this is making this complementing carry is also becoming 1. So MSB bit is 1. It means it is showing that it is already in the complemented form. So the result is already in 2's complemented form. It is negative result here. So that we obtained as like this result. So this is the result which is called as a F7H. So this is the data before. This is the data before. Now we'll see that after execution of this instruction, so this accumulator content will become here as a F7H. Then this B register content will have same. There is no change in their operand register content. So this will be 3FH itself. And this carry status, earlier we had taken 1. So now in this stage also, as per the result, this carry should be 1. So now we'll see their overall flag impact. So this is sign bit. So sign bit will have 1. So this is 1 here. And 0 bit, it will be 0 because the result is non-zero negative values. Then auxiliary carry, it has not generated any carry from this stage. So auxiliary carry will be 0. And here this parity bit. So parity bit means in this result, whatever we got it here as a F7H. So in this one there are odd number of ones because there are 7 number of ones. So parity bit will be odd parity. So this will become here as a 0. And carry status, we should not take this one. We should take this carry status after making the complement, whatever is the status. So that status will be updating as a final result of this. So this is the update, whatever we got. This is the flag result. This is the flag modification. So by this way, it is producing this result and this is the effect over the flag. So now here we have to understand about their rest of the field as a size. So as like in this one, it is having only English alphabet. So their size will be 1 byte only. And their machine cycle will be 1 only because this opcode is coming from the memory. So that operation is called as a opcode fetch. So once their opcode is coming inside the processor, then rest of the part as like accumulator content, B register content, carry flag, then their LU part where this operation happens, these all are inside the processor itself, so that it is not going to take any further machine cycle. It is required only one machine cycle, which is called as opcode fetch operation, and by default for opcode fetch operation it will take 4 T states here. So now in the case of memory, as like we can write it here as like SBBM. So here SBBM is also contains only English alphabet, so their size will be one byte only. But here machine cycle will change, because for this M, as I had explained, this M is the memory location which is pointed by the content of this HL pair. So if this HL is having 2050H, so this HL content is going to point the memory location, and at that location whatever will be the content, that content will be subtracting from this accumulator along with this carry or borrow status. So here it is going to access this memory chip two times, so that is called, their machine cycle will be two. One is called opcode fetch and another one is called as a memory read, because from this location whatever it is there in the memory chip, so from there it has to take the data. So if I am taking the same data here as a 3FH, so this 3FH along with the carry will be subtracting from this accumulator, and after subtraction the result will be stored into the accumulator without making any change at their memory location. So that is the reason for the execution of this instruction as a SBBM. It is taking two machine cycle. One is called opcode fetch, another one is called as a memory read. So as a T state, it will take 4 T state for this opcode fetch and 3 T state for this memory read. So total it will take 7 T states if the operand is considered here as a memory. So now rest of the part will be same as like, so here I can write in the note that all the flags, here in the note we can write all the flags are modified or altered to reflect the subtraction result. To reflect the subtraction result. So like this there is the changes over the flags, so this we need to consider. So in this way we had learned how this SBB works, and before making the subtraction of this B content, how this is added with the carry status, then this is subtracted from the accumulator content by the use of 2's complement method, then how it is showing the impact over this flag results, and then at the same time how to find out their size, machine cycle and T states. So I hope you understand this instruction in the better way. Thank you.